one of life's many rules that I've broken, Doug.
What, the perfection or the practice?
Yeah, it doesn't matter how much I practice.
Okay. Well, we have we have a lot of time, so
Okay, we got sound finally.
okay. So I think we rewind once again.
Yeah, sorry about this. And there we go.
Okay.
Okay, good morning, good afternoon, everyone. Welcome to GEO Week 2020. Today on Friday 6th, our first virtual panel is on challenges and approaches to data sharing, the future of open data. And my name is Anastasia Wahome, Science and Data Lead for Severe Eastern and Southern Africa at RCMRD. The general objective of this session is to discuss approaches to open data, expanding access to in-situ data and analysis-ready data for continued integration in the digital economy and sustainable development, including experience from GEO Initiatives and Flagships. And this is in support of Article 9 of the Canberra Declaration, in which the ministers, and I quote, reiterate the critical role that full, secure, and open sharing of Earth observations data and knowledge will play in deeper integration of Earth observation technologies into the digital economy, and encourage governments to increase free access to Earth observations created using public resources. End of quote. So we have 4 panelists in this session. Our first speaker is Professor Dr. Jian Zhao, and his presentation is titled In-situ Data Collection Network and Practices for Land Observation Satellite Product Validation. And he's from the Aerospace Information Research Institute from the Chinese Academy of Sciences. If you have questions, please put them in Slido at slido.com. Code is GeoWeek. Welcome, Professor. Thank you.
Okay. Thank you, Anastasia, again. And good day, everyone, again. So this is Zhu Xiang from Aircast. As you can see, my presentation title showed. Today, I would like to talk about the in-situ data collection and sharing, which is regarded as an important drive to accelerate the quantitative research and the applications of Earth observation products. So next, please. Next slide, please. Okay. You'll notice this session will address cross-cutting issue about future of open data. So please allow me briefly give you background information about existing work, then followed by preliminary understanding of our team on key issues involved in establishing a countrywide validation network, approach, and practice. Next, please. As we know, our planet has been surrounded by thousands of satellites, and the number is growing really fast with more emerging Earth observation program. US, Copernicus, China National Space Infrastructure, and Maxar Planet Labs, of course. Today, we have more advanced detector for diverse observing purpose with wide coverage, high image resolution, and rapid target revisiting. The detection accuracy and sensitivity of microwave, infrared, and laser, even this new technique, detecting technique, are continuously improved. So in this slide, you can find the global NDVI and urban expansion of Shanghai in 13 years. Both of them are very successful application case. However, a large number of observation data, including historic data, have not been well utilized, and their value has not been sufficiently exploited. Okay, next, please. Now we know for Earth observation, the observing circle becomes shorter from annual monitoring to quarterly, monthly, or real time. We also have diverse observing objective for different purposes, like from land cover change, natural disaster response, even to implementation of SDGs, to which Earth observation are expected to play much more important roles. Higher requirements on observing core variables on Earth system, from the quantity to the feature of detecting targets, from the overall investigation to dedicated management of natural resource and so on. I mean, quality and accuracy of data products determines the range and effects of satellite data and its application. So therefore, validation is really a fundamental work before you consider the wide sharing of EU data. Thus, we do need to design an independent measurement to verify and analyze the accuracy, uncertainty of remote sensing products generated from the image. And in some cases, we also need to compare the other data sources like statistic data and geospatial data and so on. Next, please. So, okay, let's have a short review on current status. Yes, this is slide. There are quite a few examples about joint validation of satellite products in various countries at worldwide, regional, or national level, like the cooperation of US and SEALS, Aeronet, and CERN on ecosystem from China. This well-organized site work serves the research community and different application field by validating and distributing the data products in different quality, in different level. So that means from those network, long-term and continuous data accumulate. Also, we all knew the national agency, institutes, university, scientists, other partner, multi-stakeholders, they all participate actively such kind of activity, especially on standardization. So we have to define the operating rules, the calibration process for instrument, even the requirements on data processing and distribution. So most programs are released the readily accessible and open database, which benefit a lot of research in different community. Next, please. Here is an example of FluxNet. FluxNet serves diverse and wide research community, which focused on the land surface modeling and land atmosphere interaction. So different regional networks are connected in FluxNet as a member of it. So they do produce a lot of data set. A newest one is Flux 2015, which includes a lot of data from over 200 sites. So we also should not forget the flexible cross-sourcing program. A lot of validation can be done by volunteers plus visualized platform with support of internet. Okay, let's go to next slide. So even so, I talk about a lot about the existing network and also different means to obtain the in-situ data. But even so, it's still quite hard for scientists and users to find appropriate or sufficient data set for diverse observation data products validation. It's really a complex work. As we know, field observation or measurement costs a lot, not only on the instrument, but also time and energy. So you have to consider a lot of factors like space or temporal representation of the geographic area, and also characteristic analysis of field are very crucial for the set selection. Regarding the measurement and processing, the sampling strategy, measuring rules are talked a lot of from very beginning in the Bigfoot and Valerie project. So integration of multi-source data also are very important for network observation, because we have to use the different platform. So if we can do that, the data collect are not missing. So for our research community to obtain the accurate in-situ data set, that is to see the true value of pixel by different scale, it requires sufficient station, instrument, and observation. So we need to establish a continuous observing system which focuses on the multiple variable in multiple scale, and try to include the useful detect means by deploying this system. Okay, go ahead, please. So the core part is still the question on the slide: how to offer the credible data for product validation. The following feature should be considered if we want to propose that solution for multiple products validation. For example, synthesis of multiple observation means, like I mentioned, wireless sensor network for LAI or soil moisture, the handheld spectrometer, UAV, and also there should be a consistent and traceable specification on measurement. It's very important for you to get the accurate result from the field work. And for better sharing, data set should be provided in a standard manner. That's why for most of us, very difficult to find useful data set on the website if it doesn't follow a uniform manner or format. And data archiving and data product portal is also necessary for improved user experience and better performance. Next, please. So here we proposed an integrated approach for in-situ data network at national level, which compares validation sites, experimental fields, calibration and benchmark laboratory, and data processing and sharing portal. There are 4 components in total. So validation sites, it is a network of separate validation sites comprised of about 15 stations at different locations. Currently, usually collect data and points over a small range, aim to provide a few kinds of parameters, conducting automatic or manual measure with support of equipment installed locally or handheld. So there are also 6 no-fixing experimental fields in this system to support large or comprehensive experiment by using most kind of in-situ instrument. I mean, it is designed for validation experiment for different kinds of GEO products. It can provide
I think your connection just broke for a second. Can you repeat the last minute, please?
Okay. I think from my side, everything is fine. Nothing happened.
Yeah, but you were. I've got a poor connection on your side, so you were gone
Okay.
for a minute.
Okay. I will go on until next slide showed. Okay. So here's an example of evaluation index system on validation site selection, as I mentioned. So we use the 7 first-class index and the 29 second, and AHP method is used to qualify the weight of each index. So that's how we select 15 validation site countrywide. Okay, go ahead, next please. As I mentioned, the instruments are a crucial factor to assure the accuracy of measurement. So we build a joint laboratory for calibration of multiple instruments from different sites and user group. I think it's very indispensable work for the whole system. Okay, please, next. So ongoing project has begun to provide validation of some specific parameters such as LAI from 14 sites in China. In future, there will be more data available for the different user, but we fully realized that benefit from such integrated network, which could make best possible use of existing infrastructure, like instrument at each station, but with minimum cost and low invest on a new facility. Second, is network can include data and scientists from different community and countries for improvement on algorithm and models. And I think the most important, the cross-verification analysis strongly support application of high quality data products and diverse application for different fields. I think this is really the final goal. Okay, next please. So for the last page of my presentation, I think our goals is to exploit the potential of observation data products The current concern still remains on the quantity and the quality of satellite data, processing speed, and the precision of data products, sharing policy, and the service model, and so on. I think the cooperation on validation data sharing under the framework of GEO needs to be strengthened, especially on following issue. They are on the slide, but I would like to explain a bit more. So we could co-develop a tailorable technology framework for GEO community, so the user can decide the validation target or network scale depending on their interest and capacity according to this framework. And also standardization, as I mentioned, is very important if you want to get a credible data set and a benchmark for the instrument calibration, processing, and distribution. Very important. I think this kind of work can be started at local level or national level. Then we can try to link different validation site work together to try to provide the more accurate and timely validation data for the global or for the research on the global issue or regional issue. So that means we need to enhance the joint research on global and regional scale on the validation methodology and also on some specific purpose in some different for some different department user. So, and the last one I want to mention is data publishing system, because data sharing, I mean the policy is very important. How to encourage the scientist and the data owner to open the valuable data set. I think we need to efficient and reasonable publishing system, but with the citation or cross-reference system. So still work need to be done in the future. So I think I talked a lot about validation network and also practice of establishing a field validation network in China. But I also want to say GEO could provide an opportunity for the whole community to build such kind of system with standard manner, and which will helps the country or members and maybe user group in GEO community to benefit from the data sharing of in-situ data. Okay, that's it. Thank you.
Thank you very much, Professor Jianzhong. And our next speaker, the second presentation will focus on best practices for data provision, both successes and challenges. And we are going to get this from Adam Lewis, and in a presentation titled Global Supply Chains of ARD, that's Application Ready Data. And he's from both CEOs and Digital Africa. Welcome, Adam.
Thank you, Anastasia. It's great to be here. And thank you, Doug and GEO, for putting on this session. Can you hear me okay?
Yes,
I'm going
you're
to take, yes.
audible.
Thank you. I'd like to acknowledge the great talk of Professor Zhu regarding in-situ data. Validation is a fundamental requirement of the scientific application of Earth observation, and field data are key to that. So I just want to get that out there. I like the flow of these talks. I'm talking about data rather than in-situ data, Earth observation data. I am talking, as Anastasia indicated, both with a CEOS hat on initially and then with Digital Earth Africa hat on. And I'll start with CEOS in the background of analysis ready data from a CEOS perspective and then talk to what Digital Earth Africa is doing about it. Next slide, please, Rick, or Doug. And the next one again, because that one's a bit out of date. Thank you. CEOS has been working on analysis ready data since 2015. Recently, in 2019, it was elevated to the point of being a strategy of CEOS, and it is now a priority of the strategic implementation team of CEOS, which I co-lead. And it has, the strategy itself has these 4 pillars in the bottom left of this slide around having specifications, about assurance of supply, about studies of pilots and feedback, and communicating the idea. Next slide, please. This slide is from the CEOS website, where the next couple of slides I'm going to speak to come from, and there are a range of materials and background on that website that can be used to understand where CEOS is at with this. Next slide, please. The term analysis ready data has a very broad appeal, but that also means that it can mean all things to all people. And the work in CEOS started with developing a very broad definition, and that took until the end of 2016 to actually come up with this definition. And what it does is captures what analysis ready data is to CEOS. That is, it's data that's been processed to a minimum set of requirements, and why. And the why is in order to allow users to get to data more easily and to use it without less effort, and importantly, to be able to use data through time as time series, and to be able to validly compare data from one area with data to another. So that's broadly the idea of interoperability. And the website is given at the bottom there. But also, CEOS recognise that definition alone is still inadequate. It can still be almost anything to anybody. Next slide, please. So CEOS then introduced this new idea of product families and specifications, and that does tie down specifically what CEOS is talking about when we speak of analysis ready data. So if you want to know what it is, ask yourself the question, how would you know if you had analysis ready data? And this framework introduced a number of specifications, and so there are specifications for each of these measurements. And the specifications broadly, I'm not going to go into them in any detail, talk of what is it you're measuring, and here you can see some listed. Is it surface reflectance or surface temperature? Where is the measurement taken at? And that comes down to how well an image is geocoded, and is it sufficiently well geocoded? There might be an expectation that the geocoding is to within a pixel accuracy, for example. What corrections have been applied to get to that measurement, and the community might decide that some corrections, like atmospheric corrections, are necessary and be looking for those as a specification. And in all those measurements, all those pixels, which ones are bad? Which ones do you think simply aren't worth using? So they might be cloud affected, for example. And those few things really are what the specifications try to capture in CEOS analysis ready data. Next slide, please. And what's happened since it took from 2016 to 2019 to actually agree on the first few of those specifications. And that's a range of people from the community, expert community, data provision community, user community, working together to come up with an agreed set of specifications. Those first 3 were on surface reflectance, surface temperature, and normalized radar backscatter. And then what happened after that is communities have become more and more interested in this concept. So after the first 3, the radar community, which had developed the normalized radar backscatter, started to identify that it could also do other things. It could talk about polarimetric radar as a product, geocoded single complex as a product, interferometric products. And they've then been working very actively on specifications for analysis ready data for those. At the same time, or shortly after, interested groups working in coastal and inland waters have identified that they really want analysis ready data for those those targets. And so the idea of aquatic reflectance as a target, as an analysis-ready data type has come up. And in 2019, space-based LiDAR has started to be spoken about, and there's discussions happening on how that could be specified as analysis-ready data. And very much more recently, in only the last few weeks, the idea of hyperspectral data from new missions like NMAP and night light radiance, as produced by NASA, have come forward asking for how can we build a specification around this. So there's a lot of momentum building around this side of things. Next slide, please. GEOS, as there's been growing interest in the idea of analysis-ready data from 2015 to today, the CEOS efforts have increased their focus on outreach. And there's been extensive outreach to the Earth observation community through CEOS itself, through GEO, and we held a plenary side event in Canberra last year looking at this question, through extensive engagement in conferences, particularly IGARS, through presentations at the Living Planet Symposium, and through what are now 3 sequential industry-led conferences called ARD 18, 19, and 20, which are years 2018, 19, and 20, as well as these other specialist conferences, VH, RODA, IVOS 32, JC, and PCORA. We've engaged with standards organizations and most recently focused on how this should be discussed with industry, and bringing in industry to these conversations is seen as vital. So CEOS has now developed an industry white paper talking about and has run webinars with industry and has been directly outreaching to industry groups to engage in the discussion. Next slide, please. So why is this all being done? So the advantages of CEOS analysis-ready data sweep across the groups. So to data producers, if the data are analysis-ready, there's going to be greater uptake in impact of those data. And whether you're a government provider or a private sector operator, that's a good thing. To data distributors and hosters and cloud operators, having analysis-ready data there is going to attract people to your platforms. And for data users, it makes the data much easier to use. And traditionally, the model of remote sensing involved 80% of a researcher's work, at least, being data preparation before getting to the key question. So ARD offers massive benefits to producers, distributors, and users of EO data. And in fact, it's now becoming an expectation of large user community groups. Next slide, please. Beyond that, analysis-ready data is essential in big data architectures. And as we move into the world of big data, so I've taken this slide from a very recent presentation that Gilberto Camara gave, talking about how you do machine learning in the era of big data, and analysis-ready data is a key input to that, as are field data, of course. Next slide, please. More broadly than that, in the data cube world, of which machine learning is a part, but there are many other applications, analysis-ready data is also fundamental. And putting on my Digital Earth Africa hat here, the model for Digital Earth Africa is that observations are captured from satellites, analysis-ready data products are created for the continent, and they become the basis for all downstream uses. So these architectures are predicated on analysis-ready data. Next slide, please. And here's an example that ISRO tabled at the CEOS plenary very recently, earlier this year, which is a tool to compare data through time. And that comparison through time, each of these windows is a different point in time. In order to do that comparison validly, the data need to be comparable through time, so they need to be analysis-ready data. And this is working with resource SAP data. So there are broad drivers for analysis-ready data, and they're all very active. Next slide, please. So what about the supply side? Whilst we have very large demand, the supply is, in a sense, still in catch-up mode. What we're all anticipating very closely is that Landsat Collection 2 will be released, and it will be the first global data set that has full CEOS analysis-ready data compliance. That is, All the requirements of CEOS analysis ready data have been studied and looked at by USGS. They meet those. It's been peer reviewed, and others have confirmed that yes, those data meet all the requirements. As I said, we're waiting that with bated breath. Anticipated, hot on the heels of USGS, as the Sentinel-2 surface reflectance, which, and I believe this is to do with getting the global DEM in place, will soon be CEOS analysis ready data compliant. Shortly after that, we'll have a USGS-based aquatic reflectance provisional product being produced, and then others will follow on from that. I'll just flag at the bottom here that there are no Sentinel or indeed any radar products that currently come out as analysis ready, and as far as I know, none are immediately planned. Next slide, please. So the big question here is how is the GEO community going to meet the demand from users for analysis ready data? And I'll put some things on. These need to be highly accessible. They need to be standardized. They must be of scientific quality. They must be machine readable. They have to be ubiquitous in coverage, that is, covering the whole globe. There has to be an assurance of supply that the data there today will be there tomorrow and that the observations will continue. There has to be consistency in management, so that there aren't changes in file formats or latency times or other factors. And they also have to be affordable. And of course, free and open data are affordable, but that doesn't mean they're affordable if they come off a commercial supply, for example. Whilst we can ponder these questions, a bunch of partnerships are forming that are actually breaking through some of these questions. So things will move and are moving as we speak. So I'll now move into the Digital Earth Africa frame and talk about what we're doing. Next slide, please. What Digital Earth Africa is doing in this space. Digital Earth Africa itself is an operational platform aiming to translate high-quality satellite image data into decision-ready information. Next slide, please. The broad idea here is that we have masses of data on the left, and that is a 2018 GEO median composite of all Landsat data for 2018 for Africa. Full resolution continental data that is informing local issues, which is what the images on the right indicate. It is powered by the Open Data Cube, so that's the infrastructure that Digital Earth Africa is using. Next slide, please. The reason for doing this is not to be broad brush in our approach, but to enable full resolution studies that deliver information that has local relevance. And here we're looking at satellite imagery on the left around Lake Baringo in Kenya, which is just a lot more full than it has been for the last 15 or 20 years, and is causing a lot of concern. And on the right, images from Kenya around Lake Baringo and its neighbouring lake that are almost merging together. There is so much water in them. Next slide, please. So what Digital Earth Africa have done in order to meet their need for analysis-ready data is several things. Firstly, we've put in place, and I'll say we at this point because I am kind of head of the Digital Earth Africa establishment team, have put in place pipelines of Sentinel-2 surface reflectance data. So Sentinel-2 data for Africa, for the entire African continent, are now coming to Africa on a daily basis. The data started in 2017 and have been processed from 2017 by Synergize, a European-based company. That creates about 1.5 petabytes of data. The data go to, presently they go to Oregon in the US, where a different company called Element 84 converts them to cloud-optimized geotips, which is what COGS are, and adds in DAC metadata, which is a spatio-temporal asset catalog. That's what makes it machine readable. And then the data flow from Oregon through to Cape Town. And as of this week, that data is flowing operationally. That's a massive undertaking, and a range of breakthroughs were made to achieve that. But what it means is that Africa suddenly has access to this massive data source. Next slide, please. And that access can look like studying agriculture in Kenya and building large-scale machine learning methods to map crops and agriculture. Next slide, please. Or it can mean looking at Mauritius and looking at what the reefs around Mauritius looked like in 2017 on an average and comparing those with what they look like in the 20th of October 2020 after the oil spill that happened in July, August and has damaged a lot of that reef system. So there's very broad-ranging applications and opportunities for wide applications within Africa with these data sets. Next slide, please. It also means that others have access to these data. So already we have Esri, who are part of DE Africa and have built a geoportal, independently accessing those data sets and looking at how they can build further analysis and further access to them for more users. Next slide, please. What hasn't happened so far is we don't have a radar-based pipeline. We're expecting the Landsat pipeline to come through, and that will come straight from USGS, but there is no Sentinel-1 radar pipeline. But we know that's an important data set. It's important in equatorial West Africa, where it's almost never a clear day. And it's important elsewhere to help monitor things like crops. So we are in fact building and have in advanced development a pipeline of Sentinel-1 radar analysis ready data. This will be, as far as I know, the first in the world, certainly at this scale. There's a processing system which will be run by Synergize to produce normalized radar backscatter. It will be fully compliant with the CEOS radar backscatter product family specification. It will go through the same process of conversion to cloud-friendly formats and be synchronized to Cape Town. And we think that's going to be running in early 2021. And that's a pretty exciting development. It will produce, we think it's going to require about 750 terabytes of data to do from 2017 onwards, and there'll be daily update. And we've planned to maintain that for a year, but really it's a model that we hope that the space agencies will pick up and take forward. Next slide, please. So where's all this headed? For Africa, and this is my second last slide, for Africa, this means there's massively increased opportunity to apply Earth observations for sustainable development. It can be used for local applications through to continental products. Methods that are developed in one area, and we've seen some of this from Brian Kilo's work, can be picked up and moved relatively easily to another area. So if a tool is developed that detects coastal change and monitors coastal change in Senegal, that can be moved to Mauritius or Madagascar. The data are accessible to any users. This being an open platform, we have open data coming in, we make open data going out, means that whether someone is a researcher or a private sector innovator or a government user, they can access it. They don't have to access it through interfaces that Digital Africa makes. They can also access it through interfaces that others make, such as Esri. And we really see this African situation as a test bed. Yes, it's world leading, but it's producing practices that can go global. The work that we did to establish the Sentinel-2 pipeline for Africa, Amazon Web Services are now picked up and are doing globally. Brian Kilo from NASA and the CEOS Systems Engineering Office is putting together a capability to build data cubes on demand, which will draw from global analysis-ready data suppliers. So anywhere in the world, people will be able to set up a data cube and have the data immediately available. And the Sentinel-1 data is really part of a proof of method and a test of demand for radar analysis-ready data. Okay, final slide. So in conclusion, demand is growing for analysis-ready data that's highly accessible, standardized, scientific quality, machine-readable, ubiquitous, supply-assured, consistently managed, affordable. Everybody benefits from that. Data producers, data distributors, users all benefit. And they benefit because the Earth observation pie grows massively the more users can be in there. It's really, in my view, absolutely core to the mission of GEO that this can be achieved. GEO wants Earth observation to count. Those Earth observations are going to count, then we have to move through analysis-ready data and its accessibility. Very importantly, and reflecting on the Canberra Declaration, the private sector is emerging as a vital enabler in multiple roles, whether it's companies like Planet delivering analysis-ready data from their own satellites, through to companies like PCI who will generate analysis-ready data, or companies like Google and Amazon who are grabbing data and putting it on their platforms, through to application specialists. The private sector has a huge role to play as an enabler. But there are obviously going to be challenges and opportunities, and questions like who will maintain or authoritative reference collections of these data are unanswered. In fact, I don't think anyone's even engaging with them. And so I put it to GEO that as a multilateral forum whose mission is connected to this, dependent on it, there's a need and an opportunity, I think, to start to explore what's the strategic perspective that needs to be taken forward globally. What are the opportunities for public-private partnerships? What are the roles that government satellite producers, data producers can play, and how will they work together to make this necessary infrastructure come into being? Thank you, Anastasia. I'll stop there.
Thank you, Adam. Very enlightening presentation. I think it's good to hear that we are really moving forward on analysis-ready data. Now, our next presentation will focus on the digital economy and sustainable development, including experiences from GEO Initiatives and Flagships. And this is from Mir Martin from the International Center for Integrated Mountain Development, that's ICIMOD. He's a theme leader for geospatial solutions and also the science and data lead for the severe Hindukush Himalaya region. And his presentation is titled GEOGLOWS Enhancing Flood Early Warning in the Hindukush Himalaya region. Welcome, Mir.
Thank you, Anastasia. Can you go to next slide? Yeah, so I'm Mir Matin from ICIMOD. I think Anastasia already mentioned. Maybe you can go to next slide. So my presentation will be, I will give a brief introduction to ICIMOD and Surveyor program, and then issues on the flood hazard and early warning in the Hindukush Himalaya region, and then how GEOGLOWS streamflow forecast are supporting it, and then how we are using the in-situ data and sharing to validate the product and some challenges. Next, please. So International Center for Integrated Mountain Development is an intergovernmental organization based in Nepal with 8 member countries, including Afghanistan, Pakistan, India, China, Nepal, Bhutan, Bangladesh, and Myanmar. It is a knowledge center focusing to improve the resilience of mountain people in the region. Next, please. Surveyor is a NASA-USAID partnership to improve environmental management and resilience and climate change by strengthening the capacity of government and other stakeholders to integrate Earth observation, information, and geospatial technologies into development decision making. And Surveyor has hubs across the globe, and that like in Asia we have a hub in Kathmandu and Bangkok. We have 2 hubs in Africa, one in the east and one in the west, and 1 hub in Latin America. And the ICIMOD hosts the Surveyor Hindukush Himalaya hub and focusing 5 countries in this region that include Afghanistan, Nepal, Myanmar, Pakistan, Bangladesh. Next, please. The Hindukush Himalaya region is a vast area. It's a source of 10 major Asian river system, 8 countries, 210 million people in each case. But the region itself impacts almost 1.3 billion people, which is a huge part of the whole globe. Next, please. Flood is a major disaster in the region. Every few years we have a major flood, while every year there are some floods occurring in the region, and that causes huge damage to the life and properties. Like the recent flood, like you see 2017 there was a big flood, and 2020 there is a big flood, and you can see that like in 2017 more than 600 people were killed only in India. So this is a big problem to tackle. And then early warning system can support one of the major support for mitigating flood. Next, please. So what are the issues in the current early warning system? Like we don't have enough lead time, limited information content, generally not proven to operational purpose, and then we don't have skill set in the region to provide and update the system regularly to provide solution. Next, please. So now I give a brief on the GEOGLOWS. What is GEOGLOWS? GEOGLOWS is a system that based on a global model that is running in European Center for Medium Range Weather Forecast, ECMWF. So GEOGLOWS has a paradigm shift considering the limitations of maintaining individual forecast that has to have end-to-end solution that includes hydrological model, visualization system, everything. So these traditional models had some problem that user agencies many of the time does not have the skill or resources to update their model regularly. So normally generally models are developed with one time or sometimes with the external help, but then it is not updated because the capacity is not there. So GEOGLOWS come here with a paradigm shift. In the paradigm shift, what do we mean by that? Like that modeling and then user visualization analysis, these two are separated. So like here, the modeling system is run by ECMWF, and they have the infrastructure, they have the expertise, and then they have all the resources regularly update and then develop the model. And then when user have on the other side, so what GEOGLOWS does it is this interface. So develop a visualization system and then data access system based on this ECMWF forecast system to provide develop custom application to the user. Next, please. So what is the approach? Go to next slide, please. Sorry, yeah, okay. So in the GEOGLOWS approach, what we do is, as I mentioned, that the land surface hydrological model are used to generate stream flow warning at delineated stream segment for the whole globe, and then that forecast then accessed through the simple web service, and this web service could be designed at various scale, and information content can be visualized as per user need. So that's the whole paradigm shift and approach that we have taken here. You go to next slide, please. So what we do is methodologically, like what is the forecasting process. The ECMWF generate global forecast like model graded land surface hydrology at using 52 ensembles. This forecast is generated for 15 days. So then what we do is this forecast then we transfer in the GEOGLOWS process, transfer to stream segment as a stream flow, and this system was developed by Brigham Young University and under NASA Surveyor Applied Science Team project. And then this stream flow is routed to the downstream segments using a rapid hydrological model developed by NASA JPL, and then an open source application framework developed also by Brigham Young University called Tethys, and that is used to develop customized application for data access. You go to next slide, please. So now I go some example. One of the example I'm giving this transboundary river flow in Bangladesh. As you know that when you have to do any kind of hydrological forecast in Bangladesh, where 94% of the flow is coming from upstream river basin. So any hydrological model to build in Bangladesh need to access data or forecast from upstream. But problem in the region is upstream access to the upstream data, in-situ data as well as forecast is very limited and not on time. So that is a big limitation for developing a hydrological model with a sufficient lead time to serve for Bangladesh. We go next slide, please. So with that in mind, we have developed a custom application that using the GEOGLOWS global model to provide a streamflow forecast for all river segment in the whole HKH region for the river basins. And then I'll come in a future slide that so that we also collaborate with different countries to validate this forecast, so that then in terms of accessing the data as well as understanding what are the bias and other quality of the forecast, so they can have a good access. And then collaboratively, we are working with different countries to validate the data and then forecast and provide feedback to ECMW. I'll come to later. Can you go later? Next slide, please. Here's another example that so that the earlier one I have given that is a forecasting system for all the river segment for all HKs. But then Bangladesh Flood Forecasting Warning Center, they want a more custom application that they can use. So they have 17 transboundary station that is required as a input or boundary condition for national hydrological model. So we developed a custom application for Bangladesh Flood Forecasting and Warning Center, where they can visualize GEOGLOWS forecast for those 17 stations, as well as they can download the forecast for input as a boundary condition to the national hydrological model. And that actually improved the quality of hydrological modeling in the country a lot. Can you go to the next slide, please? So next, another application in Nepal. So in Nepal, there is no good hydrological model for the whole country. So normally, Department of Hydrology and Meteorology provide flood forecast by curating forecasts from different agencies like ECMOD Regional Outlook System, RIMES Hydrological Model, and also they used to access the GLOFAS system, which is also a previous visualization from ECMWF, which is now being replaced by GEOGLOWS. But at that time, the visualization system was only few major river in Nepal. So that was the issue, and then the lead time that they had earlier was very short for maximum 3 days. Go to the next slide, please. So we customized the GEOGLOWS for generating a national forecasting system for Nepal only, and also and a visualization system that also give the coloring of the river based on the probability of flooding in terms of return period, which was generated based on the reanalysis data for 30 years in terms of stream flow for different segments. So that gives a very good overview that which are the rivers that are coming in next 15 days have some potential for running above different return periods. So this also gives us a very good access to forecast in a very user-friendly manner. Can you go to next slide, please? The next slide, I show that now that we have a regional system and also that is customized for different application for national or like transboundary. We also have some example for very local watershed that we are working with community organization. But while all these systems are customized for individual user, but the background application and the modeling is the same. So that's why all these organizations are collaborating to validate the forecast. And since the systems, all those systems are consistent and accessing the same forecasting, the joint validation process actually gave the good understanding of the whole system, and then that feedback can go to the ECMWF to improve their modeling, and which can then again come down to all users and benefit everyone. And then they don't have to maintain any hydrological model and then maintain that in their own organizations. Can you go next slide, please? Here is an example of validation in two examples, one in Nepal. So this is one example in Nepal. Like we have compared to simulated data with the in-situ data. And we see that there is a difference between the amount of peak, but the pattern is very well captured in the simulation. Can you go to the next slide, please? Okay, so now we have some challenges. Challenges is that sometimes we have forecast quality is not that what you can say expect up to the mark in the mountainous region where rivers are more flashy. So we are now actually working with the Department of Hydrology and Meteorology to understand actually where is the error source, so that can be feedback to the whole modeling process, or if at all this model can capture that. So that is also important that to understand where this model can be useful and where it is not. And then we are providing forecast on the river, but the impact of the forecast is not always understandable. So there what also we are now thinking towards how this forecast can be integrated with Earth observation data for generating inundation forecast. Another problem issue is challenge is dissemination. So at this moment, so that is what we are working with all these organizations, that now that they can focus more on concentration on dissemination instead of using a lot of resources for maintaining the model, improving the model, updating the model, those kind of things. So we are working with them with various source and various customization of the application, like using mobile system, using mobile app, web system, and then all kinds of customization. And another problem is challenge is access to more in-situ data, because these data are still different organization and different country has different data policy. We are still working with them, and they are seeing the benefit and then coming more into the sharing of data for validation. Next slide, please. This is my last slide. So we are seeing that some way forward that we are still working with all this organization with this some kind of common agreement to continue this validation with all these partners, and then provide feedback to ECMWF to improve their model, and building the capacity to our agencies to how to access this data and how to analyze this data, how to do the validation, and then give the feedback, and then coordination among different organizations to understand each other, what are the issues of the model, because as I told that we are using the same model so that any understanding of validation exercise can benefit another user. And ECMOD as a regional organization is playing a good role, coordination role in the region. And we are using Surveyor and ECMWF collaboration is another way forward to improve this, strengthen this further. And we are actually working with the ECMWF, and also GEO can provide. And actually our PI, Jim Nelson, is behind this development, all these GEOGLOWS. And so we are seeing that collaboration is also a very big part of this strength, which is also way forward. Thank you. Thank you.
Thank you, Mir. Very insightful presentation. Our next presenter is Dr. Toshio Koike. And first, I want to congratulate him. Yesterday, he got the Individual Excellence Award from GEO. And he's going to be looking at regional perspectives. And he's the Executive Director for International Center for Water Hazard and Risk Management, and also Professor Emeritus of the University of Tokyo. His presentation is titled River Basin Disaster Resilience and Sustainability by All in Asia and Africa. Welcome, Toshio.
Thank you, Anastasia. I would introduce the river basin disaster resilience and sustainability by including the people and local stakeholders. We are focusing on Asian Africa. By the way, so we can classify 17 SDGs into 5: quality of life, food, water, energy nexus, built environment, environmental concern, and social systems. Goal 17 are the different category, but these 17 are closely related together. We need to understand the structure. By the way, under climate change, the number of the event of the water-related disaster increases, and also the impact has been intensifying. So the damage occurs on built environment and the environmental concerns at first. The impact is propagated to food, water, energy nexus, and quality of life. At the end, the negative impacts occur on the social system. We need to understand this mechanism as a whole and consider how to reduce this water-related disaster impact, and also we keep the sustainable development. So how can we achieve these goals? We have a lot of the satellite data and Earth observations, but the society, on-site stakeholder, it's very difficult for them to use these data and information fully. There is a gap between the society and stakeholders, and we need to fill the gap between the exchange of the data, information, and knowledge. And not only the Earth Observation Society, but also in general, science community, we have a gap with the society or on-site stakeholder. To fill this gap, we would propose online synthesis system which has a function of the exploration, collection, archive, and a search of the scientific information in their mother tongue, not only in English, but also their mother tongue is very important in conjunction with socioeconomic data. And also prediction, simulation, visualization, and data integration and information fusion are very important. In addition, we need to coordinate among the various disciplines, and also we need to encourage mutual risk communication, the disaster risk and environmental risk communication between society and the science community. Then this information can support consilience, the integration of the scientific knowledge by providing this information. So can we fill the gap between the science community and the society? Maybe no. We need one more function. That is the facilitator. Facilitator is not just as a master of ceremony, but as a catalytic beings which can develop a trust-based relationship with society, and which can clarify the problem structure, and which can suggest the goals, and suggest the governance structure and a possible solution, and provide understandable explanation, so make sense. Then we need to develop some tools for cultivate the facilitators under this COVID-19. So e-learning system is very, very effective. Then the new viewpoint which is created by the science community can be passed to the society via the facilitator. And user needs, local knowledge and data can be also passed to the science community via facilitator. And science community can provide and propose a new framework to the online synthesis system, and this can provide opportunity for fresh learning by integrating scientific knowledge. So in this way, we can fill the gap between society and the Earth observation community. So we are now trying to develop this kind of the framework in Africa, under the project of the UNESCO, funded by the government of Japan. The water disaster platform to enhance climate resilience in Africa, WADIR Africa, was established last year in focusing on West Africa, Niger River Basin, Volta River Basin, but COVID-19 happened. So by using the GS map, this is a satellite, the rainfall product, and the past rainfall data in this region, bias collected real-time, the GS map, the product is available in real-time basis, and by using this bias collected satellite data, we can learn the hydrological model in a seamless way from the drought stage to the flood stage in the continuously. And the flood and inundation mapping is monitored. Maps is monitored. And such kind of the inundation flood map can be overlaid with the land use map. This is one of the city of the Togo, Sansani Mango, and then the flood hazard map for this municipality can be developed. This information can be shared with the local municipality office, and the inundation depth, duration, area can be shared, and these time series flood simulation result can be used for making a timeline of the emergency response assigned to each responsible sector of this municipality. This description can be developed. To realize this kind of the capacity, we developed the one-week e-learning for experts, including the 3 introductory lecture and the 3 tutorial program, totally 6. And this is 1 week, the e-learning training, including the self-evaluation test. So at the first the e-learning program, 48 participants from 11 countries and 27 have passed this self-evaluation test. So the regional the leader, the agreement, and the Volta River Basin Authority and Niger River Basin authorities are now providing the next opportunity. So total number of the participants, the target is 300. So next opportunity will be held next week. So following this e-learning for expert, we have another program, 1 week e-learning for facilitators. So 40 participants will be selected from the 300 trained experts, and this program includes on-demand training and also online deep discussion with selected participants who have completed the 1 week e-learning expert training. So the much more mutual discussion, communication. This facilitator will give get some capacity. So this is also the 1 week training. So this is now ongoing in Africa, and in Asia we have already developed a platform on water resilience and disaster by integrating the damage data and socioeconomic data as well as the hazard data, and integrated risk assessment from past, present, future, including the societal change, also the climate change, by monitoring, by identifying the past change and the current monitoring and the future prediction. Then we can provide usable information for policy making and community of practice. So data archiving, model development, and societal benefit creation through the interdisciplinary collaboration and the transdisciplinary collaboration. This framework is supported by Japanese data integration analysis system, DIAS, and also the capacity building program is included in. So this framework is now ongoing in 4 countries. In Philippines, the Ministry of Science and Technology and the Ministry of Public Works and Highway under secretary working as a co-chair. So many departments and universities are joined. And in Myanmar, 4 key departments, the Director General of these 4 key departments, they meet together and under the 2 national council under the Vice President. They are working together with many departments and universities. And in Sri Lanka, they have already developed the so-called online census system, the flood forecasting system, and they try to use this output by various departments and also the agriculture, irrigation, and the disaster management center are working together. Indonesia, this platform has just been established. 4 ministries at the central government and focusing on one river basin, Solo River Basin, in collaboration with local centers. The framework has been already developed. So they are now planning the e-learning system based on the online census system. So to develop the collaborative framework for achieving the SDGs at the normal time and also at the time of a disaster. Of course, we need Earth observation data, conjunction with socioeconomic data synthesized by online system, and this information can be shared by the facilitator with society toward the river basin disaster resilience and sustainability by all in Asia and Africa. Thank you very much for your attention.
Thank you very much, and I think with that, we have reached the end of the presentations, and we are going to go straight into the questions and answer session. And I see there is quite a number of questions for our speakers. But first of all, before we go into all those questions, I would want to give about 1 minute to each of the speakers to tell us what each one of them thinks is the most significant progress they would like to see made through GEO over the next couple of years in terms of open data. And I will start with Professor Jiang. Please give us your view of the most significant progress that you'd like to see made through GEO in the next couple of years in terms of open data. And each one of the speakers is going to tell us what they think about this. Thank you. Professor Jiang.
Okay, thank you, Chair. So as I mentioned, I think GEO can play important roles on the enhancing the cooperation between the different community under the framework of GEO, because GEO has a very good organization mechanism which convey the power from the member country and POs. A lot of PO are especially focused on the research community on thematic area. I think we can, the very important thing for GEO, we can try to define a framework to guide the methodology of in-situ data collection, especially the policy which can promote the construction of in-situ connection network at national level, and also with a unified or standard manner to link different scale network for regional issue, for global research. I think that will be a good contribution from GEO community. Okay, thank you, Anastasia.
Thank you, thank you. Adam, what's your view of the same question?
Thank you, Anastasia. I think that the most important thing GEO can do is actually to embrace operating at scale and embrace operational delivery of impacts from Earth observation, and to identify that research is about developing how things are done, but GEO needs to be about delivering impact and enabling those things to be done at scale. And a key part of that is data, and I push my own barrow here, and engaging with this idea of how the data are made available in analysis-ready form on a global scale, and engaging with industry as part of the solution in all those things. and moving from being industry being other to industry being partners, logical partners in the way these capabilities are delivered globally. Thank you.
Thank you very much, Adam. Mir Martin, what do you think GEO could do in the next few years?
Thank you, Anastasia. I think GEO has a very good role to play. As you see that there are a lot of analysis-ready data are being developed and hosted by different platforms. But then now you need to, for accessing those and then make out the meaningful analytics of those data needs a capability in terms of user. So GEO can do two parts. One is develop analytical tools that address different issues, like we have shown here, this flood stream flow forecast. So those kind of very user-friendly analytical tool and framework can develop. GEO can collaborate or support development, like GEOGLOWS. And another part is working with the end user to build their capacity to use those analytical tools in terms of accessing those data and get benefit out of those. Thank you.
Thank you very much, Mir. And Torsia, your views?
Okay. I think this is a kind of the last mile challenge for GEO. What is our final goal? That is the Earth observation community can contribute to the societal benefit. So we need to identify what is a gap and then make an effort for filling the gap. So I think it's very difficult to share the Earth observation data with local community. That's why it is very difficult to get the local data by us. So we need to develop a framework of the mutual communication. Such kind of the function is essential. We have a lot of the advanced technology. So I think what do we need to do for filling the gap? We need to consider that point. Thank you.
Thank you very much. And we have questions from participants as well. And several questions here. Adam, if you could tell us what are further reflections that you may have on the possible paths for capacity development in relation to Digital Earth Africa. And maybe just let me add another one that has been asked as well. How can people access the analysis-ready data that you said is already available? If you could answer those two in brief, thank you.
Thanks, Anastasia. On the first one, capacity development is vital, and Digital Earth Africa has a major part of its effort in capacity development, and we're working with regional institutions, your own RCMRD, but also with OSS and CSE and AgriMet and AfriGist, to set in place relationships where we can bring in ITC, the International University of Twente, to develop training materials, co-develop those, go through the trainer's capability, and then have those regional institutes reach out and take forward the training of others in countries where they're active. So we see the capacity development as growing, as being something that's co-designed and co-delivered with our partner institutes in Africa. That work is now just starting to ramp up. In terms of how people can access the platform that we have is publicly available, so any person can go to the interfaces we have, which are a Python sandbox. There's a map interface, a web-based map interface. They can also go to the Esri Geo portal, which is discoverable, search on Geo portal, which reaches into the same data sets or people can go to the Amazon S3 buckets where the data sit. So there are a range of ways in which people can get at the data and can help to visualize it or analyze it. Those things are all discoverable from, I'll put in the chat, Digital Earth, the website.
Thank you, Adam. And next question for Professor Kweke. And there's a comment here. One of the questions is, you have presented very interesting concepts, and but what do you, or how would you describe playing the role of facilitator in the OSS? Specifically, what would be the catalytic being? And also, I think you can answer that one first, then I'll go to the next one.
Okay. As I introduced in my the slide, the facilitator is a kind of the scientist, but who can establish the trust relationship with the community, and also who can suggest, not the inform or not the teach, but suggest how to develop the governance and how to solve the problem. So such kind of the support to the community, that is a role of the facilitator. Facilitator should not do everything. Okay, the community should do. So such kind of the science-based facilitation should be established. OSS, online census system, can support the first lead facilitator, but based on the function of the facilitator, people or community can use the OSS freely. So such kind of the concept I proposed. Okay.
Thank you. And maybe just to follow up, how would you link your work with other GEO initiatives of the GeoWork program, such as the GEO Working Group DRR, and so that more countries and institutions can benefit? Are there any possible linkages?
Yeah. Under the GEO framework, we have two channels. One is the Asian Water Cycle Initiative. The 4 countries, they are now working together with us under the GEOGLOWS. Okay. As Martin mentioned, the GEOGLOWS, they provide various functions. One of the regional activity of the GEOGLOWS is the Asian Water Cycle Initiative. The 4 countries, as I introduced, Indonesia, Philippines, Myanmar, Sri Lanka, are now participating in this framework. Another framework is the DIAS, Data Integration and Analysis System. This is not the flagship, one of the GEO activity funded by government of Japan. So this DIAS is not only just the data system, but this is the kind of the catalytic function for making a maximum use of the Earth observation data and information for societal benefit. So these two framework are the GEO. By using these two GEO framework, we are now trying to realize this function.
Thank you.
Okay.
And the next question goes to Professor Jiang. And you mentioned in your presentation the need for consistent standards for data measurements and exchange. Do you think GEO should be more proactive in setting standards? And also, do you think the GEO's infrastructure should be hosting in-situ data? So you can answer those 2 questions. Thank you.
Okay. Thank you, Anastasia, I think both of them are good questions. As I explained in my presentation, I think GEO, what GEO can do is not only a portal. I mean, provide a platform for the data exchange or service for inquiry or searching the data you want to do. I had an investigation several months ago. Scientists who are working on the producing 30 meters land cover data set. He is trying to validate the accuracy of his data set. They found a lot of data from website, but I think less of them were useful for him, for his research, and he has to do a lot of extra work to maintain this data, to rebuild the structure, try to find the useful things from the data set. I mean, for GEO, GEO, as I mentioned, not a portal. I think can actively act as a coordinator because it has a very good coordination mechanism with the country and the organization, those actively participate in the activity of GEO. So I think for standard, we can have a special working group on organizing such kind of open discussion, try to help spread the experience from the activities of the US or sales, such kind of validation site. And also, I think because this site, I mean, existing sites cannot cover widely for the different purpose. So the standard, or I mean, the uniform manner should be proposed to help those country or organization to build their validation system or network following the proposed methodology. I think that helps the producing of the valuable in-situ data. That's the first question. And also, I think if we talk about the GEOS platform, I think the portal has a very good mechanism, DAB. So the in-situ data definitely can be included the sharing structure of the GEO portal, and also for GEOS, as Adam mentioned, the validation data set is I think it aims to provide the support for producing ARD data. So I think it is a very indispensable part of GEOS, and as very important sharing contents of GEO portal. Okay, that's it.
Okay, thank you very much. And my next question goes to Mir Martin. And in your presentation, you stated you've worked with several government and agencies in the flood early warning. Maybe you can tell us, because in the Canberra Declaration, the ministers encourage governments to increase free access to Earth observations using public resources. From your perspective and experience in your initiatives, what are the chief impediments that keep this from happening? I think you're muted, Mir.
In the context of flood early warning, there are a few things that needs to be addressed. First is the capacity of government agencies. First, we need to have a collaboration, a partnership, so that we need to address them what data and what information we are going to work with them and develop, and how that would be used for them is if that is a part of their that can value add to whatever already they're doing something. If that can add value, then only they can be interested. And then second part is how the capacity of the agencies to use this data. And third part is in the context of flood early warning, because this is a sensitive information that government agencies or mandated organizations are providing to public to reduce or mitigate the disaster. So they also are afraid of like false warning or inaccurate warning. So that's something is, so they are what we have collaborated with them that, okay, like in Bangladesh, before they take anything into operational, they need at least 2-year validation to get understanding and confidence of the system. So we worked with them in order to validate and jointly validate and see how this system can actually give them meaningful information so that they can use that for quality and more reliable warning. So that is another part, like this journey together to take that hard work in order to see and validate some kind of the system so that they feel also confident. So they are what we have to work with them in terms of. So this is a more important is that you have to take them together in the journey in terms of building the system, building their capacity to understand the system and use the system, and also verify the data and products so that whether that data they can rely on. So that's something the ownership build on, and that only they can, they are also willing to use it. Thank you.
Okay.
Anastasia,
you're muted,
we don't
Anas.
hear you.
Apologies. So another question for Adam Lewis in relation to Digital Earth Africa, and do you have a strategy for in-situ data at Digital Earth Africa? And maybe the next one is brief in terms of ARD data for Sentinel-1 and 2. And maybe you could tell some of the participants who are interested how soon they could be able to get that.
Thank you, Anastasia. First up, in terms of a strategy for in-situ data, yes, and let me just endorse Mia's comments there about how fundamental it is to be developing things with users. And one of the lovely intersections there that we've found is the importance and value of engaging communities in Africa with the validation of products, and it's through that process that not only do we get validation data, not only the accuracy is increased, but people come to understand and engage with and own the product. And so we have a validation strategy. We started on that nearly a year ago, and we've worked with Severe in particular and use their Collect Earth Online tool. So we're partnering with Severe, and we're using our regional partners to collect data using Severe and using that to test the accuracy of our surface water maps and to validate and capture reference data for agricultural monitoring tools. So we do have a validation strategy. It's a fundamental part of what we're doing, and we've been very happy with its progress so far. In terms of, I think the second question was about Sentinel-2 analysis ready data. Was that it?
Yes, Sentinel-1 and Sentinel-2 analysis ready data.
So the Sentinel-2 analysis ready data are already available. It's been running for since roughly July. We've had those data. That's data is actually moving to Cape Town now, as Amazon have moved their capabilities, and we've got them in place there. So the Sentinel-2 is already available. Landsat will be available as soon after the United States Geological Survey Complete Collection 2, which may be later in November, but the dates have kept moving back. And after, when they release it, there'll be a period of a month or two before it's available. Sentinel-1, depending upon Landsat, we may have Sentinel-1 early in the new year, or it may be slightly later in the first half of 2021. But I think all those will be in place.
Thank you very much, Adam. And at this point, I want to thank all of our four panelists. Thank you very much for the insightful presentations, for the discussions. Thank you, participants, for listening and for the questions. In case you did not get your question answered or did not get a chance, you can